Hi everyone, today's note is on tangents and normals. So far we already know that a tangent is a straight line that touches the curve at a single point. A normal, however, is new for you, and that's basically a straight line that crosses perpendicularly or 90 degrees to where the tangent touches the curve. So if I was to draw a curve, any curve, doesn't matter what it looks like, so something, let's say, similar to that, and I was to pick a point, let's say here, my tangent line would look like that, goes through only that point. My normal line will go perpendicularly to that point. So, in order to find the equation of a line, we need two things. Basically, you learned that in grade 9, and the first is a slope, and the second is a point. Now, we've already done a couple questions like this, so this shouldn't cause too much difficulty for you. So try it out by yourself, and then check your work, but here we go. First part says find the derivative. So f prime of x is 2x. Second part says find the gradient or the slope at that given point. So f primed at 1, which is 2 times 1, which is 2. Find the point, so f at 1, which is 1 squared plus 1, which is also 2. So the point is 1, 2. Pure coincidence that the slope and the point are the same thing. Doesn't matter. Find the equation of the tangent line. So 2 over 1 is equal to y minus 2 over x minus 1. That's 2x minus 2 is y minus 2, so y is equal to 2x. There's the equation of my tangent line. Again, a question like this shouldn't take you longer than about a minute and a half to do. You should probably be able to get it down to about a minute and see where it goes from there. All right, next question here. Determine the equation of the normal. So first of all, circle, highlight, underline that part of the question because that's the most important part of the question, to the function where x is equal to 4. Now, a common thing for students to do is to do the question the exact same way that they did the question just before. And at the very end of the question, they'll make the slope in the question a negative reciprocal. Well, you can't do that at the end of the question because basically you found the y-intercept using your tangent slope. So you've now changed everything. So please, please, please make sure that you don't do that in the question. Follow along, make sure that everything's all right in the way that you do the question here, and change the slope at the according point, at the according time, not later on in the question. So let's start out. First of all, I don't like the way that this equation is written because I can't change it. So I'm going to change it into a form that I can use, which is 8x to the negative a half, because remember, a square root in the denominator when I move it up becomes negative a half. Now I can take the derivative. So f prime of x is 8 times negative a half x to the negative a 3 over 2, which is negative 4, and the square root of x cubed. Now another way to say this is negative 4 over the square root of x all cubed. There's no difference in these two, except in this first one, I would cube first and then square root. And this one, I would square root first and then cube. This second one is better because when I square root the number, it becomes smaller, and then I cube it, which becomes bigger. However, the other one, I cube first, so I'm square rooting a bigger number. So basically, I want to be able to work with whichever form is easier for me to work with depending on the question. So keep that in mind. All right, next part of the question says f primed at 4, which is negative 4 over the square root of 4 all cubed. Notice that I used the second version over here because if I square root first, it's a lot easier for me to then cube it as opposed to cubing 4 first and then square rooting it. So that's negative 4 over 2 cubed, which is negative 4 over 8, which is negative a half. Well, negative a half is the slope of my tangent. Notice I've written a little subscript of a t. The slope of my normal, therefore, is the negative reciprocal, which is 2 over 1. So this is the point at which I want to do this, not at the end. I want to do it now. All right, next I want to be able to find the point. So I want to find f at 4, which is 8 over the square root of 4, which is 8 over 2, which is 4. So my point is 4, 4. My slope is 2 over 1. I can now find the equation of my line. So of my normal is 2 over 1, y minus 4 over x minus 4 2x minus 8 is equal to y minus 4. So y is equal to 2x minus 4. This is the equation of my normal. Okay, please make sure you follow all the steps, and that of all the steps, this one here is in this particular spot. So once I find the slope of the tangent, I then quickly find the slope of the normal by doing the negative reciprocal. This question is a common question that students will make errors on because they're not paying attention and they try to do it the same way they've been doing the other questions, and they just flip it at the end. Again, you cannot flip the slope at the end. You have to change it in the middle of the question before you use it to find the equation of the normal. Okay, next question. Determine the coordinates on the curve f of x where the gradient is 11. So the first thing you say to yourself is, what is this question exactly saying to me? Well, it's telling me that the slope is 11, and I want to know where on this function the slope is 11. So in order to find the slope, I basically have to take the derivative. So step 1 is take the derivative, which is 3x squared minus 1. When I take the derivative, that's equal to the slope, so I set that equal to 11. So 11 is 3x squared minus 1. 3x squared is equal to 12. X squared is equal to 4. That means x is equal to plus or minus 2. Make sure that you don't forget that plus or minus 2, because that is the clincher to the question. Well, I know that the x-coordinate of these coordinates, I need to now find the y-coordinate in order to finish the question. So basically, I want to find f at 2 and f at negative 2, which is 2 cubed minus 2 plus 2, which is 8. So one of the points is 2, 8. And the other one is negative 2 cubed minus 2 plus 2, which is negative 8 plus 2 plus 2, which is negative 4. So my other point is negative 2, negative 4. This question is not a difficult question to do. It's just challenging for some students if they're not really understanding what the question is saying. So before you jump right into a question, read it out, understand what it's asking you, and then set about doing what you need to do. So let's start with a basic question here. This is a grade 9 question here. What would the gradient be if the tangent is horizontal? What it's asking you is, what is the slope of a horizontal line? Well, that's 0 over 1, otherwise known as 0. What would the gradient be of a tangent that is vertical? Well, that's 1 over 0, otherwise known as undefined. So try this question first, and then press play again in order to tackle it together. The question says, find the equations of any tangents, horizontal tangents to be specific, to the function given. Well, if it's a horizontal tangent, that means its derivative is equal to 0. So step 1, take the derivative. 3x squared minus 12. Set it equal to 0. So 3x squared minus 12 is equal to 0. So 3x squared is equal to 12. X squared is equal to 4. So x is equal to plus or minus 2. Just a fluke, it's the same question. But now it's telling you find the horizontal tangents, which means that these are lines, horizontal lines on the graph. Well, keep that in mind as you go through the question. I need to then find the rest of the point, so I need to find y at 2 and y at negative 2. Well, that's again 2 cubed minus 12 times 2 plus 2, which is 8, minus 24 plus 2, which is minus 14. So the point is 2, negative 14. And the other one is negative 2 cubed minus 12 times negative 2 plus 2, which is negative 8 plus 24 plus 2, which comes out to be 18. So here are my 2 points. Well, I could sub in the 2's and the negative 2's and find the slopes. Or if I'm smart and I understand that basically these are horizontal lines, and one line goes through 2, negative 14, so it goes through this point here, let's say, for example. And the other one is at negative 2, 18, so somewhere over here, for example. I would be smart to know that if it's a horizontal line, my equations will simply be corresponding to the y-coordinate. So one equation is y is equal to negative 14, and the other equation is y is equal to 18. So try not to waste time, especially if you can understand the question and manipulate it in a certain way such that you can simply use numbers that are already on your page without going through the epically long process of trying to find the equation of a tangent line, knowing full well that if my slope is 0, it's going to go away anyway. So keep that in mind. Try and keep it short and sweet. Okay, next one here. It says here, find the points on the curve, this curve here, where the tangent line is parallel to this line. Well, if it's parallel to the line, that means the slopes are the same. A common grade 9 mistake is to tell me that the slope of this line is 6, but it's not. And you should be able to tell me why it's not. Well, the reason that it's not is that it's 3y is equal to 6x plus 5. So y is actually 2x plus 5 over 3. So the slope of this line is actually 2 over 1. Be very careful about that. So now that I have the slope, I know that the slope will equal the derivative of this function here. So everybody take the derivative. So y primed is negative 16x cubed. Well, that's equal to 2 over 1. So negative 16x cubed is equal to 2. So x cubed is equal to 2 over negative 16. X cubed is equal to negative 1 over 8. That means x is the cubed root of 1 over 8, which is negative also, so it's going to be negative a half. So I now know the x coordinate. I have to go find the y coordinate, so I'm going to sub it back in. So y is equal to negative 4, negative a half, sorry, to the quarter is negative 4 times negative 1 over positive 1 over 16, because negative to an even number is a positive number, which makes my answer negative a quarter. So my final answer is negative a half, negative a quarter. This question isn't super challenging. It's just about walking through it as we go along. Here, let's try this next one. Give it a shot on your own and see how it works for you. But basically, it's asking to determine the values of x, so I only need the x part. I don't care about the y part this time, for which the equation of the curve will have the same slope as the equation that I'm given here. Well, if they have the same slope, that means that the derivatives are the same. So find the two derivatives and set them equal, and find out where the x's turn out to be the same. So here we go. If y is equal to 8 minus x squared, then y primed is minus 2x. And if y is equal to x cubed minus x, then y primed is 3x squared minus 1. I set those two things equal, so I get minus 2x is equal to 3x squared minus 1. Hopefully you've noticed that that's a quadratic. So that's 3x squared plus 2x minus 1 is equal to 0. Product and sum, so product is equal to negative 3. Sum is equal to 2. My two numbers are 3 and negative 1. I'm going to split the middle term because I have a coefficient in front of the x squared term. So 3x squared plus 3x minus 1 is equal to 0. Take out my common factor. I know I'm right because my brackets are the same. And then finish off the question and tell me that x is equal to negative 1 and x is equal to a third. This last example is a true test of whether or not you remember, 1, your stuff from grade 11, and 2, whether or not you really understand what the question is asking you to do. So it says here, find the coordinates of the points, so plural, there will be more than one answer, where the tangent to y is equal to x cubed plus x plus 2 at the point 1, 4 intersects the curve. Well, I want to know where the tangent meets the curve again. And basically what I'm asking you to do mathematically is set the equation of the tangent equal to the equation of the curve and then solve for x and then go and find y as need be. All right, so everybody should be able to find the equation of the tangent, no problem. So step 1 is the equation of the tangent line. So take the derivative, which is 3x squared plus 1. Sub in the point, so y primed at 1, which is 3 times 1 plus 1, which is 4. find the equation. 4 over 1, which is y minus 4 over x minus 1. So 4x minus 4 is y minus 4. Y is equal to 4x. So step 1 is done. Find the equation of the tangent line. Step 2 now says set that equal to the equation of the curve. Okay, so step 2, set it equal. So 4x is equal to x cubed plus x plus 2. If I rearrange, I get x cubed minus 3x plus 2 is equal to 0. Now, here is where some people would be like, oh, no, she meant to have that as a squared. They're going to change it, and then they're going to try factoring a quadratic. Well, no, I didn't intend for it to be a squared. It's a cubed, and I made it a cubed, and I want it to be a cubed, so don't go changing questions that are definitely the way that I want them to be, first of all. Second here, yes, I want to try and factor, but I can't factor because it's not a quadratic, so I've got to factor a little bit differently. So this is where you kind of rack your brain, you go back to grade 11, you say, okay, oh, Mr. Mtula is telling me to either use long division or synthetic division. Hint, hint. So if you haven't already, I'd say pause the video right now, go run to your notes from last year, find out the synthetic division note, and then read up on it. Or you can follow along with this brief explanation of it. If you need more assistance on synthetic division, please come in and get it during extra help. So basically what I'm going to do is I'm going to look at the factors of 2, and basically they're plus or minus 1 and plus or minus 2. Now I have two options. I could either sub in those numbers into the equation and find the one that gives me 0, or I can use synthetic division. So I'm going to use 1 as my choice. I could have picked -1, +2, or -2. I'm choosing 1 for the sake of argument. I'm going to use the coefficients here. So 1 goes here. There's no squared term, so 0, the -3, and then the 2. So notice those coefficients. I'm going to bring down the 1, and then I'm going to do 1 times 1 gives me 1. I'm going to add, so I get 1 again. 1 times 1 also gives me 1. I'm going to add again. I get -2. Multiply 1 times -2. I get -2. When I add, I get 0. That's how I know that 1, or x minus 1, is a factor of this lovely equation. So if I break it down, this here gives me x minus 1. And this here gives me x squared plus x minus 2. And basically that's how I factor. Now this in the brackets also factors into x minus 1 and x plus 2. Well, if you were smart, you notice that x is equal to 1 here and here, and x is equal to -2. But the smart part comes in right here at the top of the question, where I already told you that it hits it at 1, 4. Hence, here's the 1. If I sub that back into the equation, I'm actually going to get 4. So that's 1 point. The other point I'm going to find by subbing it in, so y at -2, which is -2 cubed plus -2, and then plus 2, which is -8, minus 2 plus 2, which is -8. So the point that it hits it at, again, is -2 and -8. Now, this question is a very challenging paper 1 question. Agreed, wholeheartedly. It is a challenging question. However, if I said to you, make this a paper 2 question, this question would be really easy, because the only part that you'd actually have to do any work at would be to find the equation of the tangent line. Once you found it, you could put that into y1, put the original curve into y2, and solve and figure out where they intersect. And that would take you all of a second to do, 30 seconds maybe. But see how this question is not only capable of being a pretty straightforward paper 2 question, but also a really challenging paper 1 question. So tackle the homework, see how it goes. If you have any questions, please be sure to come in and get some help. Thanks.